Today we will see the lecture on finding the optimal hyperparameters through grid search. Okay. So hyperparameters means choosing the best model for the grid search. So grid search CV, that is which automates the training process of different models and provides the user with the optimal values using cross validation. What is the meaning of this? Whenever we are creating the machine learning model, you will be presented with the different design choices as to how to define your model architecture. Okay, but oftentimes we don't immediately know what the optimal model architecture, because at the starting whether we know what will be the optimal architecture for my model or for my project we can consider. For example, so if we at the starting, if we find the problem statement of the project, but whether we know how to design that model and what will be the architecture for model, no, right? So that we have to find out, right? So that's what the oftentimes means. Right now we don't immediately know what will be the optimal model architecture should be, right, for the given model, and that would explore the range of possibility. So what happen in true machine learning fashion, will ideally ask the machine to perform this exploration and select the optimal model architecture automatically. Means we have a freedom to choose any type of architecture or model, any type of architecture design, but we don't know at the starting what type of architecture should be. That's why what machine learning fashion does, it will directly ask the machine to perform this exploration and select the optimal model architecture automatically. And this process of searching for an ideal model architecture is referred to as the hyperparameter tuning. Okay. Now, what should I set my learning rate for gradient descent? What should be the learning while learning this model or while searching this model for the architecture, we have to give the learning rate also for the gradient descent. So what should I set that learning rate? What degree of polynomial feature should I use for my linear model? Means this we have to set learning rate and the how many or the degree of polynomial feature, means 1 degree, 2 degree, 3 degree, likewise. Okay, so that we can show with this example using the scikit-learn, right? So we show how to use it to find the best penalty and strength factor for a linear regression with the iris toy data set. Okay, means what should be the best penalty and what should be the strength factor for the linear regression that we are finding with the help of this data set. So we are importing this data set, that is iris, by using the import load iris, and on that we are applying the grid search CV. Okay, so from sklearn model selection, import grid search CV. So we are selecting that grid search CV from the model selection. Okay, so iris is equals to load iris, we are loading that data set into the iris. Then parameter we are considering as the penalty with the L1 and L2 penalty, and this is the cross validation, that is the strength factor C. Okay, so that value is given. Now for this this C is given for the comparison purpose. Okay, now here that explanation is given. Comparison of the sparsity, that is the percentage of zero coefficient, so this is nothing but the coefficients, right, of the solution when L1 and L2 penalty are used for different values of C. So we can see that if the larger values of C gives the more freedom to the model. If we consider the larger values for this C, that is the coefficients, so it will give the freedom to the model. Vice or the conversely, smaller values of C constrains the model more. Okay, so in L1 penalty case, this model to sparser the solution. So we classify the 8 by 8 image of digits into two classes, that is 0 to 4 against the 5 to 9. The visualization shows coefficients of the model for varying C. So for varying C means for varying different values of C, how L1 and L2 penalty will distinguish this 8 by 8 matrix we can consider, or the image we can consider. Okay. So here that is given, if C is equals to 1.00, the sparsity with L1 penalty is this, and score with L1 penalty is this. Same sparsity with L2 penalty and score with L2 penalty, that is shown over here. So we can continue that code with this by using the grid search CV. We are using the logistic regression for performing this expression, because we are applying the penalty in logistic regression only, right? So parameter grid is equals to parameter grid. So scoring, we are considering the accuracy for the scoring purpose, and cross validation, we are considering the value for cross validation as 10, and n job means multiprocessing CPU count. So for this we are fitting the data as the Iris data set and the target data. Okay. Now the best estimator that we are considering, that is the logistic regression with C is equals to 1.5 and class weight none. These are the various parameters that we have to consider for this estimator, that is logistic regression. Okay. So after that we have to find out the cross val square with this best estimator of the data with the target data by considering the accuracy and the cross validation. So that will be calculated as 0.9666. So basic grid search and the cross validation validated estimators, how it works. So by default this grid search CV uses a threefold cross verification. So by default this grid search CV uses threefold cross validation. However, if it detects a classifier in sparse, then it can be increased to fivefold cross validation. For example, CLF score X digit and Y digit considers the value for that is 0.94, but if you consider the nested cross validation, it can be considered as the array. So this is how it is to be plotted on the XY plane that is given. Find the best parameter of an SGD classifier trained with the perceptron loss. The data set is plotted in the following figure. Next, how this SGD classifier works. So this estimator, this is the estimator we can consider. What is nothing but the classifier. What does classifier does? So classifier gives the class labels to the data, right? So for giving the class labels to the data, first we have to train the data, we have to find out the classifier, and after that we have to apply that to the testing data set to give the class label to the unknown data, right? So what does this estimator implements? It implements the regularized linear model with the stochastic gradient descent learning. So this gradient of the loss is estimated each sample at a time. So in this what happened? Gradient of loss is estimated each sample at a time. So this implementation works with the data represented as the dense and the sparse array of floating point values for the features. So ये कौन से डेटा के ऊपर रिप्रेजेंट किया जाता है? अगर अरे है हमारा डेंस और स्पार्स अरे है और उसमें जो फीचर्स है उसकी डेटा टाइप्स क्या है, फ्लोटिंग पॉइंट है, ठीक है. सो फ्लोटिंग पॉइंट वैल्यूज है फॉर द फीचर्स. सो द मॉडल इट फिट कैन बी कंट्रोल विद द लॉस पैरामीटर. बाय डिफ़ॉल्ट इट फिट्स द लीनियर सपोर्ट वेक्टर मशीन, ठीक है. सो लॉस पैरामीटर कैलकुलेट करने के लिए यहाँ पे क्या यूज़ किया जाता है, बाय डिफ़ॉल्ट SVM, दैट इज सपोर्ट वेक्टर मशीन. The regularizer is a penalty added to the loss function, and what is the regularizer that we know कि it is the penalty added to the loss function. क्या करता है वो, it will shrink the model or it will slopes down the your penalty, right, or your loss we can consider. So it can be towards the zero vector using either the square Euclidean norm, that is L2, or the absolute norm, that is L1, or the combination of both. तो ये कैसे किया जाता है, by using that L1 or L2 or both, ठीक है. If the parameter update across the क्रॉसेस द, अगर वो पैरामीटर अपडेशन जो है अगर वो क्रॉस करता है 0.0 वैल्यू बिकॉज ऑफ द रेगुलराइजर, द अपडेट इज ट्रंकेटेड टू 0.0 टू अलाउ फॉर लर्निंग. मीन्स अगर किसी की वैल्यू रेगुलराइजर अप्लाई करने के बाद 0.0 आती है, व्हाट इज़ द मीनिंग ऑफ दैट पर्टिकुलर फीचर इज गुड टू फॉर द सिलेक्शन फॉर लर्निंग द स्पार्स मॉडल, ठीक है. तो दैट फीचर कैन बी सिलेक्टेड फॉर लर्निंग द स्पार्स मॉडल, ओके. सो दैट कैन बी डन बाय यूजिंग दिस scikit-learn function or the code. So that will be shown over here for different values of alpha and L1 ratio. So now best score can be calculated as 0.894, and the best estimator can be considered as the SGD classifier by considering these various different parameters. Okay, so this is all about SGD classifier or the algorithm.